Hello and welcome to our next video about solving the task like this concerning exponential function. So we are today supposed to calculate for which real parameter m the given exponential function is defined. Before we start doing calculation, the most important thing is to be clear and verify when the exponential function is defined. And as we already know, exponential function is defined if a is greater than 0, which is like strict inequality. There is no equal sign, because if a would be 0, then 0 to any power is 0, and this is not gonna be then exponential function. And the next condition which must be met is our base of our exponential function, and any exponential function base shouldn't be equal to 1, because in this case 1 to any exponent or to any power will be still the number 1, and then it's not gonna be exponential function but the constant function y equals 1. Okay, and let me just remind you very quickly that any exponential function is defined with the equation y equals a to the power of x, where a is base and x is the exponent. Okay, so having in mind this point, we will now solve one inequality and one equation. In our case, the base is everything what is written in the brackets. So it's gonna be like 3m take away 5 over 2m plus 3. And from the first condition, we'll be solving the inequality such that our expression is greater than 0. And the second condition we'll be solving is so that 3m minus 5 over 2m plus 3 is not equal to 1. But before we start, as we can see, our a, or our base, is composed or is a fraction, and the most important thing is to calculate when the fraction is defined. So basically the first thing we have to solve is to find when the denominator is not equal to 0. Okay, though this condition is met in this situation, because the fraction must be greater than 0, but just to be sure, and you'll see in the table which we'll generate later on, there will be like open interval. So to solve this, it means 2m cannot be equal, 2 times n cannot be equal negative 3, so it means m cannot be equal to negative 3 over 2. So this is our first condition, when the function won't be, our given function won't be defined. The next step is to solve this inequality. And we already know that as this is fraction, we'll be looking at these two expressions like when the fraction is positive, and it is happening when both numbers are positive, or when both numbers are negative. Then the result of this divisibility, of this division, is positive number. To find out when the expression in the numerator is positive or negative, and the same for the denominator, we first have to find out our 0 points. So let's find out the first one, which means we need to solve the equation 3 times m minus 5 is equal to 0. So it means 3m is equal 5. Yeah, okay, let me just denote the operations we do. and then we multiply both sides of the equation by 1 over 3, so m is equal 5 over 3. So this is our first 0 point, and the second 0 point we will get from the equation 2m plus 3 is equal to 0, which we basically already solved. So it means from this we can make the conclusion very easily and use the information from the previous task. It would mean that m is equal to negative 3 over 2. Why is it useful? Because these two 0 points will split or divide my number line like this. Here is negative 3 over 2 and here is 5 over 3. It's very common to use the table for finding out if the value is positive or negative, but maybe you can already determine when this is happening. But as this is the video where everybody should find almost all the information, I'm gonna do it again by using the table. So to solve this, you simply construct the table, and these two 0 points will divide my number line into 3 intervals. So the first interval would be from negative infinity to negative 3 over 2, and here the interval is open. This is what I already mentioned, and it's open because m cannot be equal to negative 3 over 2, which is coming from the condition because the denominator can't be 0. So the next interval is from negative 3 over 2 to 5 over 3, and here again we have opened interval, and this is because, as I already mentioned, our inequality is like strict inequality, so the fraction cannot be equal to 0, so you can't get 0 in the numerator, and we already know that this is our 0 point. So we don't include 5 over 3 in this interval, and we do the same for the last interval. Then you construct the table like this. You put into the second row the expression 3m minus 5, and into the third row you put the expression 2m plus 3, and you are now going to find if this expression for m's being from this interval are positive or negative. So let me use the red color. If you take any number from this interval, so let's take negative 10, so 3 times negative 10 is negative 30, minus 5 is negative number for sure. Oops, sorry. So this expression is going to be negative. From this interval, the easiest and the most clever idea is to get the number 0, which means 0 take away 5 is negative 5, so the expression is again negative. And the last interval you take, for example, number 2, which is quite close to 5 over 3. 2 times 3 is 6, minus 5 is 1, which is positive number. So on this interval, whatever m from this interval you take, this expression is gonna be positive, so it will produce positive number. Let's have a look what is happening with this expression. So the same thing apply here. You take negative 10, which is negative 20 plus 3, it's gonna be negative number, and on this interval you again take 0. 0 plus 3 is gonna be positive number, and the last interval is gonna be positive. What I want to mention here is that you can apply knowledge which you already have, because if you look at this expression, you can very easily find out that this represents linear function, and the graph of the linear function is straight line, and as argument in front of, or coefficient in front of m is positive number, you know that the function will be increasing, and it will be like moved 5 elements down, but it doesn't matter because you know that the intercept, because basically here you were looking for the intercept, with the x-axis, and the graph will look like this. So you know that all the numbers that are on the left from 5/3 are negative, and all the numbers which are on the right from 5/3 are positive, which corresponds with the values or negative or positive sign in our table. So you can simplify and not use the table with applying the knowledge about the linear function. The same thing applies on this expression. But let's continue with the table and let's make the conclusion. Basically, we are looking for the information when this expression is positive. So negative over negative, as I have already said at the beginning of the video, negative over negative is positive number. So you simply make the conclusion that on this interval it's gonna be positive, on the second interval it's gonna be negative, and on the third interval it's again gonna be positive. So you can make the conclusion from this part of the definition. Okay, this is our part, like the second. You can make the conclusion that the function is defined, but it's not like the whole function is not like the final decision. The function is defined if m is from the interval negative infinity to -3/2 union 5/3 to the infinity. So this is the conclusion from the second part or second column. This is like our first conclusion. Okay, but as you can see, and I said it like twice, m cannot be equal to -3/2, which is already included in this conclusion or in this solution. And the last thing to solve or have a look at is when this expression is not equal to 1, but in this case, instead of solving is not equal to 1 is easier, and I think more common, we will be solving the equation 3 times m minus 5 over 2 times m plus 3 is equal to 1. Okay, I'll say later on why, and you will see why it is like more clever idea. So basically in this case we can multiply both sides by the expression 2 times m plus 3, which will lead us to the equation 3m minus 5 equals 2m plus 3, which is really like simple linear equation. So let's do the operation minus 2 times m plus 5, okay, which means m is equal to 8. Okay, and now as we change from cannot be equal to 1 to equal to 1, now we make the final conclusion or decision that m cannot be equal to 8. What can you do here? Very easily, you just do the quick check. So you put number 8 instead of m in this expression, and you'll calculate by head. So 3 times 8 is 24 over minus 5 is 19. 2 times 8 is 16 plus 3 is 19, so 19 over 19 is really equal to 1. So m cannot be equal 8, because if it would be, then the function will not be defined. So let's make the conclusion, and our conclusion is that the function is defined when m is from the interval -8 to -3/2 union, and that now it's gonna be like 5/3 to 8, not included, okay, open the interval, because we have to exclude number 8, union 8 to to the infinity. So this is our conclusion, and this is the solution of the task. So our given function, in this case, oops, this is not my function, sorry. So given function, which is defined by this equation, is really defined only if m is from any of these three intervals. Be careful, because this is not solution and it doesn't say anything from the previous video. This doesn't say anything about monotonicity of the function, so we cannot simply say right now if the function is increasing on this interval or decreasing, because on all of these intervals the function can be increasing or decreasing. We would have to solve another or we should then apply another conditions to find out. Okay, but if you want to remind or think about it, you can watch the first video, which was recorded before, when we were solving when the function is increasing based on the definition of the equation and depending on the values of m parameters. So I hope you enjoyed the video and everything is clear. Have a nice day and see you soon. Bye.